Hi everyone, I'm doing the computer-based test assignment for stochastic calculus for financial economics. So I'm doing the question 6 for this video. And before we start off with the question 6, which involves chooser option, we will discuss about what is chooser option. Okay, so basically chooser option will have timeline T0, T1 and T2, which normally we say T1 is T or T2 is big T. Okay, so during T0 is the time where we purchase option A, and T1 is when we have the option to choose for put option or call option, and T2 is the maturity time. Okay, so before we enter into a chooser option, we do not need to decide put option or call option at T0. We will instead choose at T1 for which where we want for put option or call option. Rationally, we will choose for put option or call option based on the value. So for example, if the call option have more value at T1, then we will choose for call option. Then if the put option have more value, then we will choose for the put option. So we can denote that the payoff is the maximum of the call option and put option. Okay, besides that, the option for us to choose for put option and call option, it also depends on the underlying asset where it is going upward or downward. So for example, if the underlying asset is going upward, then we will choose for call option as it has a higher value at T1. And if the underlying asset is dropping from T0 to D1, T1, then we will choose for put option as it has a higher value. Okay, for the payoff for maximum call option and pull option, we can take out this call C out. So it is equals to C plus the so it is equals to C plus maximum 0 P minus C. So we have the put call parity formula, which is C minus P equals to SE negative delta T minus K exponential minus R times T. So we will sub it into the equation which P minus C, we just exchange it and we will have this formula which is equals to, we take the constant out, then we will left out with the ST here. Next, we will combine the negative R and the delta, then we will be maximum 0 KE minus R minus delta times T minus stock price. Okay, so basically this maximum, this one is equals to the formula for put option, which for this situation, the K star, we just label it as K star is equal to K times exponential minus R minus delta times T, which is equal to this one, which is labeled as the put option. Okay, so for the price of the chooser option is just equals to the call option with the big T plus exponential minus dividend times T of then times the put option with the small t. But please remember this K star is equals to the new strike price, which we do not use the old strike price. We need to times with the exponential minus R minus delta times T. Okay, besides this chooser option formula, we are going to use binomial tree when solving our question 6. So for the binomial tree, we have a few formula with which is the UD. The U is equals to exponential R minus delta times H plus the delta times the plus sigma times the square root of H, while the D is equals to exponential R minus delta times H minus sigma square root of H. And the probability of going up is equals to exponential R minus delta times H minus D over U minus D. Okay, and this CO is the call option or the put option, which is equals to the exponential minus RH times the probability of CU plus 1 minus probability times CD. Okay, so let's look at our question 6. Okay, given that the currently price is at 44, which the K and the initial stock price is 44. Volatility 0.24. Interest rate is 0.06. 24 months, big T equals to 24, whereas small t equals to 12 months, because grants the holder the right to choose between a put or call option after 12 months, with each of length of 1 month, which each equals to 1/12. Okay, after we have this data, we can calculate U, D, P, and Q using the formula we discussed just now, this few formula. U, D, P, and Q, which is 1 minus P. Okay, back to our questions. Okay, for this table, we are doing binomial tree, but instead of the binomial tree, we do normally, which we draw the tree out, we will do using the Excel in the table. Okay, so let me explain how to change the data into a table. For example, we have a stock price UD U squared UD D squared U U squared D UD squared and D cubed. So we need to find the relationship because this is the normal way we do if we have 1 or 2 period, which we can calculate it manually. But for this question, we have 24 period. We are unable to calculate until 24 period because it will be a very, very long and hectic process. So this one until the period 24, we will have U24, U23D, U22D2, U21D3, U20D4 until D24. So for our stock price will be equal to S0 times this, all of this. So basically this is the column for stock price. Okay, the formula, the way of doing this one, which is equal to this part, which is basically this part for this column of table. Okay. So after calculating the stock price, which we use the the stock price times the number of U, the probability of the U times U to the power of number of U times the D to the power of number of D for each one. So the payoff, okay, for this question, we are doing the call. So basically, if the payoff will equals to 0 and okay, so for this question, as it is a call option, so when the strike price is larger than the ST, then we will not use the call option. If the stock price is larger than the strike price, then we will run the call option. So for example, for this payoff, we will use the stock price 261 minus the strike price 44. equals to 217 until when the stock price is smaller than the strike price, then we will have zero payoff because we will not exercise the call option. Okay, for the probability, part, right? We are just calculating the probability of this U24, U23D. So for this probability is U24, which U UB10 is the U to the power of the P to the power of number of U times Q to the power of number of V. Okay, so the number of combination. Okay, the number of combination, for example, is U20. For example, for U23D, the number of combination where we learn in probability is 24 factorial over 23 factorial times 1 factorial, right? So for we will put this in table and calculate the number of combination for every number of V and number of U. So we will be using the factorial formula, factorial for the first one, the factorial 24 or because we have 24 periods, so factorial 24 or factorial D15, factorial of number of V times the factorial of number of U. So the total probability will equals to the probability times the number of combinations. While the last column is where we use to calculate the sum of the payoff times the total probability, which we will use column F times with column I. This is the payoff times the probability where we will sum them out. Okay, after summing up everything, we will calculate the call price by using the summation times the exponential negative of R times 2, which is the formula of this one. This E minus RH. 2 is because that H is equals to 2 years, 24 period, but 2 years. Okay, next. Since the formula is the call price plus the put price, we will need to calculate the put price also using the same method actually. By using the same method, just the payoff it's 0. Oh, just the K, we need to calculate the new K, which is using this formula, the new K. So we will calculate it using K times exponential, this formula. We will calculate the new K and then the rest of the table is using the same method. But for the payoff, because this is the call option, is the put option just now we did is the put option. So the payoff is if the stock price is larger than the strike price, then we do not exercise the put option. So and vice versa. So we calculate out the payout, the probability, and the rest will be the same. But for the put price, right? With the formula just now, we have for this formula, after calculating the put price and the call price, we still need to times this in front of the put. So we will do this here. We will do this here. We will times exponential to the power of negative R. After calculating everything, we will just plus the call and put. And this is the final price for the chooser option. Next, let's talk about question 7. A London-based fashion designer is expecting to receive 100 million yen from a Japanese company in 1 year. the company decide to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of 0.055 per yen. Given the following information, we are required to calculate the cost of hedging using a 12-period binomial tree using pound denominated and yen denominated. Okay, so we will be doing using the Excel. Okay, first we will calculate the cost of hedging using pound denominated first. So by using the pound denominated, the X0, the exchange rate is 0.005, which is given by this one. Then the strike price is 0.0055. The volatility 0.08, the risk-free rate for pound is 0.035 because we are using pound denominated, so the local currency is the pound, and the risk-free rate for the foreign currency is 0.055. The H is 0.08, which is 1/12 because we are calculating it by monthly, and the UD and P is the formula we are using in question 6. We discussed in question 6. So for this table is actually the same concept of the as what we discussed in question 6. By using the UD, and we can calculate out the stock price after 1 year and the payoff. For these questions, we are using put because our underlying as a London-based company, we are receiving 100 million yen, which is our underlying asset, and we would like to sell it for pound. That's why we are buying a put. That's why our payoff, if the stock price is higher than the strike price, then we are if the stock price is higher than the strike price, then we are not exercising the put option. That's why our payoff is 0. If our stock price is lower than our strike price, then we will exercise the put option, and the payoff will be equals to strike price minus stock price. So we are using the if function. If the stock price is larger than strike price, then we'll have 0. If the strike price is larger than the stock price, then will be equals to strike price minus stock price. That is our payoff. For the probability, we are calculating using what we discussed in question 6 also. The combination by using the factorial times up the probability with combination, then we can get the total probability, and times with the payoff, we can get the summation of the whole payoff. By discounting the payoff, we can get to time 0, we can get the put price 0.000592 pound per yen, and we now have 100 million of yen. That's why we will times with 100 million times the put price equals to 59216.293 pound per 100 million of yen. Next, we will calculated the yen denominator. Everything will be constant except we will be flipping the by using 1 over exchange rate and 1 over strike price for the yen denominated. This one we will be using 1 over 0.005, and this one will be 1 over 0.0055 because this one is yen denominated, and we will buy a call instead because we are having the local currency is 100 million and the underlying asset is pound. That's why we need to buy a call instead. Okay, so the table, the calculation will be the exactly same as the concept is the same. Just for the payoff, for this one we are buying a call. So when the stock price is higher than the strike price, we will have a payoff because we will exercise the call option. We will because we want to have we would like to buy using the strike price. That's why the payoff is the stock price minus by the strike price. When the stock price is lower than the strike price, then we would not exercise the call option. That's why our payoff will be 0. Then we can calculate the probability, the combination using factorial, the total probability. All of this we have discussed already in question 6, and we times the payoff with the total probability to get the payoff. Then we sum them up, and then we discount back to time 0 to find the call price at time 0. Okay, this one is 21.533197 yen per pound. So if we want to calculate, because now we have 100 million of yen, we need to know the quantity. So we divide by the strike price, which we are at the price we are expecting. Then we can calculate out the quantity and times with the call price. Then we will have 11843259 yen. Okay, so to double check the answer, we can actually use the pound denominated price, which is equals to the pound divide by the exchange rate. Then we will get the same answer as this one. Okay, next we will discuss about question B. To calculate the price of the option by conducting a Monte Carlo simulation of 100,000 iteration. Okay, first we will all of these data we can get from the part A just now. So we will generate 0 to 100,000 iteration. And for the U, we can generate using the RAND, R-A-N-D. And we can, here we have 100,000 data. The z-score we will be finding using the inverse normal distribution of the U, so we can find the z-score. And the exchange rate, we will be using the formula, which is this formula. Oh, okay. We can choose to use the put or the call option here, but we choose to use the put option. So our local currency, the risk-free rate for is pound is 0.035 and the foreign rate is 0.055 for the yen. So we will be using this formula to calculate the exchange rate. Then the payoff will be equals to the K minus the exchange rate or 0, depends on because we are using the put. So we compare it with the strike price, with the exchange rate. So our formula here is the maximum of strike price minus the exchange rate or 0. So okay, after calculating all the payoff, we will calculate the expected payoff by using the average of the payoff. Then we will calculate the price of the option by discounting back to time 0 and times with 100 million yen. So our price of the option is this answer 59,110.34108. Okay, that's all for my question 6 and question 7. Thank you.